Hello everyone, myself Michael Ravina, Associate Professor, Department of Computer Science and Engineering. The subject is CS 3551 Distributed Computing. The unit is Distributed Mutex and Deadlock. In this video, we are going to discuss about algorithms for the AND model and the OR model. CHANDY-MISRA-HAAS algorithm for the AND model. The CHANDY-MISRA-HAAS distributed deadlock algorithm for AND model is based on edge chasing. This algorithm uses a special message called BROB, which is a triplet which includes I, J, K, denoting that belongs to the deadlock detection initiated for process PI, and it is being sent by the home site of the process PJ to the home site of the process PK. A BROB message travels along the edges of the global WFG graph, and a deadlock is detected when a BROB message returns to the process that initiated it. CHANDY-MISRA algorithm has the following step. A process Pj is said to be dependent on another process Pk if there exists a sequence number of processes Pi to Pk such that each process except Pk in the sequence is blocked, and each process except Pj holds a resource for which the previous process in the sequence is waiting. The process Pj is said to be locally dependent upon process Pk if Pj is dependent upon Pk and both the processes are on the same site. Each process Pi maintains a Boolean array dependent where dependency of j is true only if Pi knows that Pj is dependent on it. Initially, dependent of j is false for all the I and j. This is the algorithm. The first step of the algorithm, suppose if Pi is locally dependent on the itself, then it declares a deadlock itself else for all Pj and Pk such that the following actions are performed. Then after that, on the receipt of a probe ijk, the site takes the following actions if Pk is blocked or otherwise dependent or otherwise Pk has not a reply to the all request. Then begin dependent on particular key. If k equal to j, then declare that Pj is deadlocked else for all Pm and Pn such that all these conditions are involved. This is the algorithm for CHANDY-MISRA for algorithm. A BROB message is continuously circulated along the edges of the global WFG, and a deadlock is detected when a BROB message returns it to a initiating process. Performance analysis. One BROB message is sent and on every edge of the WFG which has two sides. Thus, the algorithm exchanges at most m of n-1 divided by 2 messages to detect a deadlock that involves m processes and that spans over n sites. The size of the messages is fixed and it is very small. Delay in detecting deadlock is order of n. The CHANDY-MISRA-HAAS algorithm for the OR model. The CHANDY-MISRA-HAAS distributed detection algorithm for OR model is based on the approach of diffusion computation. A blocked base determines if it is deadlocked by initiating a diffusion computation. Two types of messages are used in the diffusion computation. First one is the query of ijk and second one is the reply of ijk, denoting that belong to a diffusion computation initiated by a process PA and are being sent from processes Pj to the process Pk. A blocked process initiates deadlock detection by sending a query messages to all the processes in the dependent set. If an active process receives a query or reply message, it discards it. When a blocked process Pk receives a query ijk message, it takes the following actions. If this is the first query message received by the Pk for the deadlock detection initiated by Pi. If this is not in the engaging query, then PK returns a reply message to its immediately provided PK has continuously blocked since it received the corresponding engaging query. Otherwise, it discards the query. The process PK maintains a Boolean variable weight of k. When the blocked process PK receives a reply of message, it decrements the num value. Then a process sends a reply message in response to the particular engaging query. Only after it receives a reply to every query message. The initiator process detects a deadlock when it receives a reply message to all the query messages it had sent out. Algorithm. This is algorithm for the CHANDY-MISRA-HAAS model. First, send query of ijk to the all processes pj in the dependent set. When a block process pk receives a query, then if it is the engaging query of the process, then it send the query message to the dependent set. When the process pk receives a then send a reply message. When a process pk receives a reply, it waits of tk, then decrement the particular value, then declare suppose if it is any deadlock, then it declares, otherwise it send a reply message to the particular set. In practice, several diffusion computation may be initiated for the process, but at any time only one diffusion computation is currently for any process. However, messages for outdated diffusion computations may still be in transmit. The current diffusion computation can be distinguished from outdated ones by using the sequence numbers. The performance analysis. For every deadlock detection, the algorithm exchanges query messages and reply messages. Where E, that means E query messages and E means where E equal to n into n minus number of edges.